Hi guys, for this video, I just wanted you to recap a bit. So during my first video on forces, I was trying to show you that to motivate you into learning about forces and mechanics is the applications. The type of applications you'll be able to solve by learning about forces. So for this video, I want to do the slope one that I told you about. Hopefully you'll learn how to do this first by learning about components and horizontal and vertical components, okay? And then we get on to actually solving an actual problem that is similar to this one. So let's get going. Okay, so here let's say we have, like a 25 newtons of force, okay, directed in this direction, okay? And now we want to find out the horizontal and vertical component of the force, okay? Because it's not on the x-axis and it's not on the y-axis. A force on the x-axis or just any magnitude would be in this way. You would have a nice arrow here, okay, and it will be like 20 newtons, and this would be a horizontal the horizontal 20 newtons on the horizontal axis or x-axis, okay? And you can have another one basically this way, which then would be on the y-axis if you would if you put coordinates and stuff. So that is how it would be. But in this case right here, what we're having is kind of like a bit of a both. So you have something on the x-axis and something on the y-axis, okay? It's very important to learn for this concept is that this is a right angle triangle, as you can see here. So basically, that one of the angles has to be, from the three sides. It'll only have three sides, is a 90 degrees, and any other two thetas, okay? So it's very important that one of them will be 90, and then you can coordinate, you can see how it is. So to explain to you basically what the sides are, I'm going to teach something that I learned from school, which I felt like was pretty easy to understand, so assume that, we'll have any kind of just random right angle triangle, okay? So here we would have the theta, okay? And basically wherever the theta is, wherever you're putting your theta, not the 90 degrees one, the one that you want, then it's going to be this one. This one would be what we like to call the adjacent side, okay? And then the one that is right opposite to it, on the other side, not the big one, would be calling it the opposite side. Okay, that makes sense, right? And then in this one, you would have the hypotenuse, okay, which is the biggest one. Okay, so it's like a combination or adding of opposite and adjacent side would give you the hypotenuse, the square of them, through Pythagoras theorem. All right. So a pretty easy rule, to understand how to find about time theta, cos theta, and tan theta is to remember this. SOHCAHTOA. SOHCAHTOA, which means that if you can find this, okay, so S here, well, I'll put it here in green, is sine theta. So sine theta would equal, okay, opposite over hypotenuse, okay? Cos theta would be adjacent over hypotenuse. So if I wanted cos, I'll take the value of this over the value of this, okay, and that will give me cos theta, okay? And this is just trigonometry stuff that's helpful to know when it comes to solving some problems that have to do with it. Something I'd like to add, that might be useful for you to know is like, okay, sometimes you might want to find theta, let's say, in any mathematical problem. So basically, if sine theta would equal, opposite over hypotenuse, then automatically shift sine, where you put it on your calculator, sine to the power minus 1, opposite over hypotenuse, will give you the value of theta, okay? So that is if theta is not given to you in some kind of problem where you want to find it out, it would be good that you use that method. Okay, so guys, coming back to the first problem that we had in hand, now we're trying to find out cos theta. Okay, we're trying to find out this side. Okay, so how we're gonna do this is by using cos theta. Okay, and remember, SOHCAHTOA. So ka is adjacent over hypotenuse. So again, so this we're gonna say that this is A. This is just for the you know, to make it more mathematical theme. So cos theta equals a over 25, because we already have the value of the hypotenuse, the big one, which is 25. So obviously a would equal 25 cos theta. Okay, so it makes sense. So thus here we would say 25 cos theta. Now we need to find out about sine theta. Okay, and sine theta would basically be same thing. So sine theta, as we said, opposite over hypotenuse. So it would be O over 25. Thus, O would then equal 25 sine theta. Okay? I think that sounds pretty simple. Our O would be here, which means this is 25 sine theta right there. So there we have it. We have the horizontal component, okay, x-axis, let's say, all right, horizontal component, and this would be on the y-axis, or the vertical component. So this, I think, then we always have these, we have both components, so then we can use them when we need to solve the problem that we already showed in the application previously. Okay, so let's say here now we're going to the example that we really want to solve. So you have a block that's moving down the slope, m, at an angle theta, which is this one. So now we want to find the force that it's causing it to move down slope. It's not moving by magic, you know, that this is where physics comes in. So okay, to start with, first of all, you need to know that every object experiences gravity, obviously, thanks to Newton's discovery. So gravity always acts downwards. Okay, this is G. You know, no matter what, whether you take G, whether you take downwards positive or not, the direction of the gravitational force is always downwards, and it is approximated to be in this Earth to be 9.81, okay, newtons, the force, and yeah, that's, you know, to 3 significant figures, and if you want it to 2 significant figures, it will be 9.8. Okay, you can go check out my video in significant figures, you know, to help you sort this out a bit. So therefore, this object would be exerting a gravitational force. Okay, and the gravitational force is the weight. All right, so the weight would be mg in this case. Okay, so the mass of the object multiplied by the gravity will give you the weight of the object, or the gravitational force. All right, and we also need to know that because this is residing on a surface, it will have something that we call a normal force. Okay, this is almost as like something opposing to the gravitational force. Okay, and that would be the direction is this way, which is basically perpendicular to the surface that the object is in. So the normal force will always be perpendicular to the surface that the object is rested upon. And just so you get a glimpse of how it is perpendicular, so you have here an arrow and you have this as 90 degrees. Okay, so that's how basically it will be perpendicular. Now we're gonna use what we learned with trigonometry to solve this problem. Really, that's really basically all it depends on. So we're just gonna create a side surface to go with n, just an imaginary dotted line that's going on the symmetry of the normal force. Now, according to symmetry, also, if this is theta right here, then this must be theta. Okay, if you can tell me, you can put on the comments if you need me, you know, to describe this a bit more, and I can try, but just all you should know for now is according to symmetry that this would be theta. Okay, and we're just gonna connect the two lines right here and assume that this is 90 degrees. So basically right here, we have, like, you know, another right angle triangle. All right, just this little area. So what are we going to use this for? This is actually how we are going to determine the value of the force. All right. So as we said, let's assume that mg is 25. Okay, so mg equals 25. So that means that, okay, the hypotenuse is 25. So then if we can use the rule that we had, which is k, right? This is where you have the adjacent and the hypotenuse. So basically cos theta again would be adjacent over hypotenuse, which means that A would be h cos theta, which if we substitute will become 25 cos theta. Okay, whatever, all you have to do is just plug in whatever theta you have. If it's 20 degrees, you just plug it in, all right? And that will give you the value of the adjacent, okay? So what you need to use this if you want to find out the normal force, okay? So basically, from this side then, that this is 25 cos theta, which will give us the value, since it's balanced out with the gravitational force, that N equals mg cos theta, or in our case, 25 cos theta. Okay, so we're done with the normal force here. Now we want to find out the force that is causing the movement of the object in this direction. As you can see, this is the direction of the acceleration. Okay, now as you can see, we're on the verge of finishing this. Okay, so now this is the opposite. Okay, right here, this is basically the force. So what can you use O in from the SOHCAHTOA? Well, from so sine theta equals opposite over hypotenuse, and in our case O would equal 25 sine theta. Okay, so basically the force thus in this direction, okay, F would equal 25 sine theta. Okay, that's it, that's F, and when you're down that you have F, if you can find the acceleration if you wish from the formula that A equals F over M, and you're done. This is really simple. So all you have to do is just remember trigonometry. Remember that when theta is there, you just draw another line of symmetry from N, dotted line, and then draw a right angle, kind of a small right angle triangle, so that you can use it to figure out the force. Now, of course, for the sake of simplicity, we'd assume that the surface is 100% smooth. It means that it doesn't have friction. If it had friction, we'd have to like put friction on the other direction here, and we'll have friction, let's say, and then it could be static. Due to friction, the object might be in equilibrium where it balances out the forces. But for simplicity here, as the first problem, we made it that there is no friction, and friction is nuisance in this case. But in reality, almost most surfaces must have some kind of friction. So this is kind of just stuff that exists in theory only, if you will. Okay, here guys, I want you to give it a shot and try this problem. Now, honestly, the only thing that's tricky here or different is that it's been put on the other side. So just think about it a bit when it comes into symmetry and solving it. So you have a block of mass 7 kg moving down the slope at an angle of 27 degrees. All you have to do is just find the force that is causing the motion. Okay, and that's all you have. And theta here would be 27 degrees, just so you see it. Okay, I'll give you just a moment to think about it. I'm trying to solve it and then come back. Okay, so the first thing I did was just draw the gravitational force in its direction downward, 7g, and the normal force, which is perpendicular to the surface of the object. Now what we're going to do is just draw this line, okay, which goes along with the normal force. According to symmetry, if this is 27 degrees, this would be theta, okay, and same almost as previously as the earlier problem, okay, this then would be the hypotenuse, which is 7g, and this would be the adjacent, and this would be the opposite, okay, and this is the direction of the acceleration, which is A. I want you to get into the practice of using the method that I'm going to show you. So we're going to find out the resultant force, in the direction of the normal force. So we use the nice letter R in the direction of the normal force, nothing new, would then equal N, if we're taking N as positive, the direction of N, yes, in this way. So this is a positive 1 minus 7j cos theta. Now, where does 7j cos theta came from? From what we practiced earlier, it's basically the adjacent, which is A, and since we have A, that means ka, right? So basically, cos theta equals A over 7g. A would then equal 7g cos theta. Okay. Now we're going to resolve in the direction of the acceleration. Okay. Which is then going to be, so now we're resolving in the resultant force in the direction of the acceleration. And that simply would be, okay, 7g sine theta minus 0, because the friction is 0. So we're assuming 7g sine theta minus 0 as it is in a smooth horizontal surface. And simply, just again, from the idea that sine theta would equal f over 7g. And just to put a value for this, basically that means that, f equals 7g sine theta, which would then equal, as we said, 7 multiplied by g, which is 9.81 sine 27. That would give you 31.2 newtons, 3 significant figures. Or in SI units would be 31.2 kilograms per meter second squared. So I hope really that, following this video thoroughly, you are able to solve the application example. So hopefully you would have mastered this after some practice and some problems in mechanics, that you'll be very comfortable with this kind of prototype. Soon, shortly, hopefully we'll be able to solve this one. I'll get to explaining pulleys and things like that, hopefully soon. So see you in the next video. Thank you for watching. Please subscribe and like if you enjoyed the video.